Okay, thank you for the time given to me. In this occasion, I want to present our paper with title Another Parallelism Technique of GLCM Implementation Using CUDA Programming. But first, I want to introduce the member of this team. First, Tim Sar Panggabean, Mario Simaremare, Rusmina Sihaan, Chandro Pardede, and Wiwin Gurning. In this presentation, I will discuss about introduction, purpose, methodology, and proposed method, experiment, and last is conclusion. Introduction. Feature extraction aims to get the spatial characteristic of an object that can be applied to produce the desired information. The feature extraction in this paper we use the second order statistical that discovered by Haralick. One of commonly used algorithm for feature extraction is gray-level concurrence matrix or GLCM. To compute GLCM value from an image, we need high computation time. Why? If we calculate the GLCM value from an image, we need to check the co-occurrence pairs of pixel in an image. So per row of matrix image, we need to check uh, one by one, so it need high computation time. So the purpose of this research is to find and apply GLCM computational parallelization technique using GPU and CUDA programming model. The first is gray-level concurrence matrix. It's count the number concurrence of pixel pairs. For an example, if we have the matrix value of image and then we want to calculate the GLCM from an image, so we have to check the occurrence of pixel value 0 0 pairs of 0 0 in an image. So we have to check each row how many times the pairs of 0 0 in this image. In this big image, the occurrence 0 0 is 3. So we save 3 in matrix GLCM. And if we want to check the occurrence of pairs 1 and 1 in this image, so we have to check 1 per 1 row of the image pixel. So it will be need higher time to if we check it sequential. The solution is we check it parallelly. So we check per row, do it together. So we don't need check it sequential one by one per row. The next is CUDA. CUDA is one of programming model that produce parallel programming. The basic tasks that we need to know to organize CUDA include copy your data from CPU memory to GPU memory using CUDA memcopy host to device, and then invoke the kernels and configure the use of grid, block, and thread to operate the data stores in GPU memory. And the last, copy data back from GPU memory to CPU memory using CUDA memcopy device to host. In one device, we have grid, and each grid there are many block, and for each block there are many threads. So we can do one task or several tasks in one moment. So do it parallel. In this paper, we use data parallelization. So we can calculate one function in one big data. Our proposed method is the first is 1 cross n. The main idea of this method is we propose is dividing the data per row into each block and calculate the GLCM value in parallel on the GPU. So if we have uh, a matrix image 4 cross 3 matrix image, and then we divide it each row into one block, and then each block will calculate the GLCM value parallel. So it need it must be need uh, minimum time than sequential. And the second method is 2 cross 2. Uh, we divide the image with size 2 cross 2 and count GLCM value in parallel. So if we have 4 cross 4 matrix image, then we divide it into 7 section of the image, and then we calculate it parallel. Uh, so the time of calculation will be lower than sequential. In this experiment, we make series of experiment. The first is we choose different size image composed of 128 cross 128 until 1024 cross 100 and 1024 to measure processing speed. In this experiment, we choose 12 features of parallel compose from contrast until homogeneity. And the third is we test the program on different devices. First experiment we do in device GeForce GTX 1050. The calculation on GPU more efficient than using CPU. The orange line show the time execution using GPU, and the dark blue line the time execution using CPU, and the speed up the different how many times we need to the different with CPU and GPU show in blue line. And the second experiment we do in device GeForce GTX 930MX, and the calculation on GPU more efficient than using GPU. The orange line show the time execution using GPU, and the blue line show the time execution uh, in CPU in second. So the speed up of the using GPU then CPU show in the blue line. The third experiment, we do the experiment in 8 angles. It means we do the calculation in 8 angle 0, 45, 19, 135, 118, 217 until 300 and 315. And the fourth experiment, this is the diagram uh, with execution time based on angular with both method, and then the execution time based on image size on both method. Uh, from this figure, we get the computational time using method 1 more efficient than using method 2. And then in this execution time based on image size, the execution time using method 2 better than execution time using method 1. In experiment 5, there is the difference time using both method and sequential execution. So the better execution time is shown from the that our proposed method. It's better than the sequential because our proposed method do calculation GLCM in parallel. Then the sequential do it calculation GLCM sequentially in CPU. Conclusion. The first is we propose to technique implementation of calculation GLCM to get second order statistical features from an image that are 1 cross n and n cross n, where n in this paper is 2. And then we get a range of speed up from 455 volt to 4169 volt when using NVIDIA GeForce GTX 1050 and 499 volt to 1000 volt 168-fold when using NVIDIA GeForce 930MX. On future work, uh, although this research achieved good result, it can be improved by zero copy memory and adjust image size to the number of threads used for both methods. That's my percentage, and I say thank you.